In this lab, we will be considering Newton's second law to predict the motion of a falling object. We know that Newton's second law says the final velocity of an object is equal to its initial velocity plus a net force times delta t. In order to predict a falling object's velocity, the net force will be non-zero, and the net force will be equal to a weight force plus a drag force. The weight force is the product of the mass of the object times gravity times movement in the negative y direction. The drag force is proportional to the velocity times a constant b that will be estimated during the lab. So first, here is a video that I took of me dropping a sock. Then I plotted the trajectory here in Excel. Next, I ran the computation in Python. The estimated weight of the sock is 0.17 kilograms. The initial velocity and the initial position are set at 0, t is at 0. Delta t is at 0.033. We have our g for gravity and j hat for movement in the y direction. This is the model that I used in Python. Here I first estimated the weight force, which is the mass times gravity times movement in the y direction, and it's also negative. Fnet is set equal to the weight force, and then I estimated the velocity by iterating through, just like in the lectures. The blue line here is the predicted trajectory according to the computation model, and the red line is the actual observed trajectory. As you can see, there's a little bit of a difference here towards the end that is probably due to the drag force. So the next thing I did was I estimated the drag force. And here, Fd is the drag, ball velocity is just the sock velocity, and then I estimated the drag parameter to be 0.095. This was actually the fifth. I tried 5 different values, and this one came the closest. And what do I mean by the closest? Well, we can see here that the green line is the trajectory with a drag force added, and it comes very close to following the original trajectory of the observed values. Therefore, we can see that using Python, the computational model came very close to predicting the actual trajectory that the sock fell, once we accounted for weight as well as drag.